Welcome to another new topic today. Today's topic is cream separation and processing. So today we are going to discuss about what is cream, the classification and different types of cream, the properties of cream and the factors affecting the properties, and then we will understand the different methods of cream separation, especially more details about centrifugal separation of cream, and then we will understand about the processing of cream, that is different type of cream like canned cream or plastic cream or sour cream or frozen cream. So let us understand more details about cream today. First is about definition of cream. So cream is the portion of milk which is rich in milk fat, or we can say portion of milk which has been gathered and contains a large portion of milk fat. When milk fat is concentrated into a fraction of the original milk, that portion is known as cream. As per FSSAI, that is the modern scientific authority for all aspect of food quality control, the cream is the product of cow or buffalo milk or a combination thereof which contains not less than 25% milk fat. So this gives a clarity about what is cream or definition of cream. Now, classification of cream. Cream may be classified broadly into two categories. One is called market cream. This is used for direct consumption. Another is manufacturing cream. That is, this cream is used for making or manufacturing different dairy products like ice cream or butter or ghee, etc. Now we will see the types of market cream. So firstly, there is table cream or light cream or coffee cream, which is often consumed. That will have a fat percent of 20 to 25%. Then there is whipping cream or heavy cream. That will have a fat percent of 30 to 40% milk fat. And the plastic cream, that is specially increased with high fat, like 65 to 85% fat. So we should remember these three things: light cream, heavy cream and plastic cream. Light cream 20 to 25, heavy cream 30 to 40 and plastic cream 65 to 85% fat. Now let us understand some of the important physico-chemical properties of cream. Firstly, it is acidity, viscosity, whipping quality and specific gravity. These are some of the important properties of cream. As such, we can see that color is white yellowish, odor it is odorless, appearance it is semi-solid, consistency it is smooth, and it is having a pH of 4. It will have a good spreadability, phase separation and viscosity. We are going to learn little more details about these properties of cream. Now let us understand some of the properties of cream. The first one is acidity. As we have already studied in case of milk, that is measured as titratable acidity or TA. So titratable acidity of all fresh cream should be consistent with fat percent of the cream. The titratable acidity of freshly separated cream is always lower than that of the milk from which it was separated. So if the titratable acidity of milk is 7, definitely the acidity of cream will be below 7. The viscosity, it is another important property. It is defined as the resistance offered by a liquid to flow. It is an important property of cream from the commercial viewpoint, since the consumer judges the richness of cream from its viscosity. So viscosity plays an important role about the feeling about the cream by the consumers. Here we will see the factors affecting the viscosity of cream. The factors are like fat percentage. So if the fat percentage increase, the viscosity will increase. the temperature. When the increased temperature, there is decrease in viscosity. Because of the increase in temperature, the fat globule get melted, so it has better flow or lower viscosity. The separation condition, that is how it is separated. If it is separated at a higher temperature, naturally it will have a reduced viscosity. Then homogenization, earlier we have discussed, it breaks the fat globules. So if the single stage homogenization, there is more viscosity. If there is double stage homogenization, it will reduce the viscosity. The rate of cooling, slow cooling increased the viscosity. Aging, whenever there is aging, there will be increased viscosity. Then clumping, that is the joining of fat globules. So it increased the degree of clumping will increase the viscosity. Here is another property called whipping quality. Whipping refers to the beating of cream to produce froth or foam. That is emulsion of gas, air in liquid. So somehow the air is incorporated into the emulsion, and that's the whipping. Whipped cream has a remarkable stability containing foam and is used in cakes, ice creams, etc. for decorative purposes. This whipping property is a very important for making the ice cream and for the property called overrun of ice cream, which we are going to discuss later. Now we will see factors affecting whipping quality. Firstly, the fat percentage. Around 30 to 35% is most satisfactory for whipping quality. Second is whipping temperature. Above 4 degrees Celsius, whipping quality is reduced progressively. In case of ice cream preparation, the mix is first reduced to a low temperature, then only the air is incorporated. Then separation temperature. The temperature at which cream was separated, that is 32 degrees Celsius, is more satisfactory. Homogenization, above 300 psi it is detrimental. Aging, as I mentioned, at 4 degrees Celsius for 24 hours it is optimum for whipping. Then acidity, increased acidity decrease the whipping quality. Addition of stabilizers. So stabilizers are used for making ice cream. So whenever the stabilizers are added, it will decrease the whipping quality. Now specific gravity. Specific gravity is another important property, as we have told in case of milk. It is as same as the density. So the specific gravity of cream will decrease when the percentage cream is more, because the pure fat has the specific gravity or density very less, around 0.9. So when the percentage increases, the specific gravity also decreases. Like in case of cream with 20% fat, the specific gravity is 1.013. When 30% fat, it is 1.004. It is reduced. Then cream with 40% fat, the specific gravity is 0.995. So higher the fat content, lower is the specific gravity. Now we will discuss about separation of cream from milk. The basic principle of cream separation is based on the fact that milk fat is lighter than skim milk. The milk fat has a density of 0.93 and skim milk 1.036. Milk, being a mixture of fat and skim milk, is subjected to either gravity or centrifugal force, and the two components, by virtue of their differing density, separate from one another. So the two part of milk, cream and skim milk, has got very high difference in the density or specific gravity. Now when they are subjected to gravitational force or centrifugal force, they get separated due to this difference in density. Now methods of separation. Basically there are two methods. One is gravity method, another is centrifugal method. The gravity method, when milk is allowed to stand for some times, there is a tendency for the fat to rise, because the specific gravity of the fat or the density of fat molecules are less, so automatically it goes towards the surface. The velocity or rate at which fat globules rise is governed by Stokes' law. So this is a law based on which the fat globules go upwards. Now we will see the factors affecting rise of cream in gravity methods. So this is as per that Stokes law I have mentioned earlier. Firstly, the size of fat globules. If the fat globule size increases, the rate of rise increases, because larger the size, more effective it will be under the gravity to go up. Then temperature. As temperature increases, that is of the milk, the viscosity decreases, and hence the velocity of the fat globule to rise up increases. Then clumping. A clump or cluster acts like a single globule, that is many fat globule joined together act like a clump. Then the effective R, that is the radius, increases. Naturally the velocity to rise up under gravity is more. Then finally, the gravity method being very slow is no longer used commercially for cream separation. It is a small scale method. Maybe at household level, if we hold the milk, it will rise. Just after boiling, if we hold the milk, much of the fat will slowly rise and make a thick layer of cream. Now we will see the centrifugal method for fat separation, that is the commercial method, and it is called as cream separator. When milk enters the rapidly revolving bowl of the cream separator, it is immediately subjected to a huge centrifugal force which is 3000 to 6000 times greater than gravitational force. While both the fat and skim milk are subjected to centrifugal force, the difference in density affects the heavier portion more intensely than the lighter portion, that is cream. So when the milk and cream is entering the bowl of a cream separator, it is subjected to heavy centrifugal force. Now the skim milk part having higher specific gravity, so it gets more centrifugal force and gets separated towards the periphery, whereas the cream part having lower specific gravity, it has got less impact of centrifugal force and it gets separated and coming towards the center of the bowl. In continuation about centrifugal method of cream separation, as I have mentioned, the skim milk is forced towards the periphery because of its higher specific gravity, while the fat portion or cream is towards the center. So they get separated due to the centrifugal force. The skim milk and cream, both from the vertical walls within the bowl, are separated and being led through separate outlets at the top. Now the cream outlet is at a higher level than the skim milk outlet, both being near the axis of rotation. Here we can see the diagram of cream separator. At the left side, you can see that there is the central entry of the normal milk, and inside this cream separator there are many hat-shaped discs. Now this cream, after going inside due to the centrifugal force, the skim milk part being heavier gets separated and go towards the periphery and go up and get an exit, whereas the cream part being lighter gets separated and comes towards the center and go up and gets separated through a separate outlet. In the similar way, there is a original photograph of cream separator we can see in the top right corner, and at the bottom there is another diagrammatic explanation about the function of cream separator. Now you will see various types of cream separator like warm milk separator, cold milk separator, power driven separator that is used in the milk plant or factory, then hand driven separator that is used in the farm for small scale, or open bowl separator that is also used for small dairies. Then there is semi enclosed separator, and then there is hermetically sealed, airtight or foamless separator. In the right side diagram we can see that milk is going into the cream separator and then skim milk is coming out. Later on the cream is going in the other way. Sometime we can produce the standardized cream from that, or sometime we can add specific cream and make standardized milk. Now we will see the factors influencing fat percentage in cream during cream separation. So firstly, the position of the cream screw or skim milk screw. We are going to discuss more details about it. Then fat percent in milk. How much fat is there in the milk? Then speed of the bowl, that is the bowl of the cream separator, what is the speed that decides the centrifugal force. And then rate of inflow of milk, that is that what rate we are feeding the normal milk. Then there is temperature of milk, that has a role in the fat percentage in the cream, and amount of water or skim milk added to flush the bowl. So we need to add water or skim milk to flush the bowl, that has a role in separation and fat percentage in the cream. So we will see the role of these factors on the cream in more details. So now we will discuss about the factors influencing the fat percentage in cream. Firstly, the fat percent in milk. Higher the fat percent in milk, higher the fat percent in cream, and vice versa. So if the milk has more fat percent, the cream also will have more. If the milk has less fat percent, the cream also will have less fat. The speed of the bowl. Higher the speed of the bowl, higher the fat percent in cream, and vice versa. That means if the speed of the bowl is more, it will have more centrifugal force, and naturally the fat percent will be more in the cream. Rate of milk inflow. Higher the rate of milk inflow, lower the fat percent in cream, and vice versa. That means if the flow of milk is very high, naturally it will not be separated 100%, so the fat percent will be less in the cream. Temperature of milk. Lower the temperature of milk during separation, higher the fat percent in the cream, and vice versa. That means if the temperature is high, the fat will be melted and it will be more difficult to separate. When the lower temperature, the more fat will be in the cream. And as I mentioned, some water and skim milk is added to flush. So if we add greater quantity of water or skim milk, that will affect the lower fat percent in cream, and vice versa. Now, position of the cream screw. As I have mentioned earlier, the position of the cream screw plays an important role in the efficiency of cream separation. The cream screw or outlet, it consists of a small threaded hollow screw pierced by a circular orifice through which the cream emerges. So this is one of the important valve-like part through which the cream comes out, and this we can put it in or out, towards in or towards out. So the screw can be driven in or out, thus bringing it nearer to or away from the center of rotation. When the cream screw is moved in, that is towards the axis of rotation, a higher fat percent in cream is obtained, and vice versa. That means if it is going towards the center, there will be more fat. If it is taken outward, then the fat percent will be less. This is because the force tending to discharge cream through the orifice is decreased. A smaller proportion of cream is therefore discharged, showing higher fat percent. Screwing out the cream screw produces thinner cream. When the screw is taken outward, then the cream will be thinner, or the fat percent in the cream will be less. Now we will see the factors affecting fat loss in skim milk. That is, earlier we have seen the fat content in cream. What are the factors? Here we will see the factor causing fat loss in the cream. So to some extent, some of the factors which we have seen earlier will be same here. So one is temperature of milk. Number 2 is speed of bowl. Number 3 is rate of milk inflow. So if the temperature is more, the loss will be less. If the speed is more, loss will be less. If the rate of milk inflow is more, then the loss will be more. The position of cream screw, as I have mentioned, the in and out. So if it is in, more efficient, more fat in cream, so less loss in the skim milk. Mechanical condition of the machine, size of fat globules, degree of agitation given to milk before separation, presence of air in milk, and acidity of milk. These are the factors which determines the fat loss in skim milk. Now we will discuss about separator slime. This is a slime-like deposit inside the cream separator. It consists of slimy mass which accumulates inside the bowl of the cream separator. It is made up of the secreting cells from the udder, fat, calcium phosphate and other minerals, bacteria, and occasionally red blood cells. The average composition of separator slime is water around 68%, fat 1.4, protein 25.3, lactose 1.8, and minerals 3.3%. So this is a deposit in the cream separator, that is called separator slime. So far we have discussed about what is cream and cream separation. Now we will discuss about the processing of cream. So first thing is pasteurization of cream. So pasteurization of cream can be done by two ways. One is by batch method or Holder pasteurization. Another is by HTST method, which we have discussed for milk also. Now the Holder pasteurization, that is also called as batch process and used for small scale handling of pasteurization of cream. The cream is heated to 71 degrees Celsius for 20 minutes or 77 degrees Celsius for 15 minutes and then promptly cooled. So this is briefly about batch pasteurization of cream. So here the temperature is more than the milk. That is, in case of milk we used only 63 degree. Here it is 71 degree and 20 minutes and 77 degree and 15 minutes. Now we will see about HTST pasteurization of cream. This is a continuous process used for large scale handling of cream. So this HTST pasteurization we have discussed for milk. Same is the process for cream. It is for continuous large scale pasteurization. The HTST pasteurization is more suited to freshly separated sweet cream than the neutralized cream. That is, when the cream get sour, we put neutralizer. So that is not very suitable for HTST. The maximum heating temperature may be 95 to 100 degrees Celsius for 15 to 16 seconds. 95 to 100 degrees Celsius for 15 to 16 seconds. This is the requirement for pasteurization in HTST method of cream. Now we will see another method of pasteurization, that is vacuum pasteurization or Vacreation. This is also a continuous process. In this process, milk or cream is pasteurized under reduced pressure by direct steam. The process was first developed in New Zealand and they called it Vacreator, and the process is called Vacreation. It was designed to remove feed and other volatile flavors from cream and to pasteurize it for butter making. So commercially it is used for pasteurization of cream, which is to be used for making butter. Now in continuation about vacuum pasteurization, the Vacreator consists of three stainless steel chambers connected to one another for steam heating and vacuum treatment with continuous product flow. To maintain the fluidity, the duration of initial cream takes place and the fat test may be lowered by 6 to 8%. So to maintain the fluidity, there is a dilution into the cream and the fat percent reduced because it is directly getting connected, mixing with the steam. Altogether, it takes the product about 10 seconds to move continuously through the unit. Here we will see how the vacuum pasteurization work, that is in the different temperature and pressure. The first chamber is operated under vacuum of 5 mm mercury, which maintains a temperature of 90 to 95 degrees Celsius. Then there is a second chamber that is maintained at 71 to 82 degrees Celsius under the vacuum of 15 to 20 mm of mercury. And the third chamber is at 43 degrees Celsius and a vacuum of 26 to 28 mm mercury, and here more of flavors are removed. So we can see the temperature in the first one is high, 90 to 95, in the second one 71 to 82, and the third one 43. Now we will discuss about manufacture of different types of cream, that is sterilized or canned cream, plastic cream, frozen cream, clotted cream, sour cream, and synthetic cream. In the other side we can see the fat percent of different kind of milk and cream. The cream part we have already discussed, that is light cream, heavy cream, and synthetic or plastic cream we have discussed earlier. Here first we will see the manufacture of sterilized or canned cream. Here the fresh sweet cream is standardized to 20% fat and then preheated to 80 degrees Celsius without holding. That is the pasteurization. Then there is double homogenization at 80 degrees Celsius using 2500 to 3000 psi in first stage and 500 psi in the second stage. Then immediately it is cooled to 16 degrees Celsius and filled in tin cans or bottles and immediately sealed. Then this sterilized in retorts. So this can, after filling, it will go to the retorts, that is the canning process or sterilization process, in which first 15 minutes for coming up, then 12 to 15 minutes for holding at 118 degrees Celsius and 15 minutes for cooling to room temperature. This is the processing schedule in the retort or canning process, that is first 15 minutes, then 12 to 15 minutes, and then again 15 minutes for cooling. So this is briefly for the making of canned cream. Now about plastic cream. This is obtained by re-separating normal cream, that is about 30 to 40% fat, in a normal cream separator. That is normal cream, if we pass through cream separator, then the fat content will increase. Or we can do it by separating milk in a specially designed plastic cream separator. In that case, the fat percentage in the cream will be very high. In both the cases, the initial product is pasteurized at 71 to 77 degrees Celsius for 15 minutes and cooled to 60 degrees Celsius before separation. Now we will see about the making of frozen cream. It is mainly used by ice cream manufacturer and for storage of surplus cream for use during period of shortage. Here the separate and standardize the cream to 40 to 50% of fat, and then it is pasteurized at 77 degrees Celsius for 15 minutes, then cool to below 4 degrees Celsius and fill into paper or plastic container or tin cans and seal well. Then it is frozen quickly, freeze quickly and store at minus 12 degrees Celsius or below. So this is the brief about making frozen cream, which is for long-term storage and which can be used any other time, especially for ice cream making. Now we will see about the disadvantage of frozen cream. The fat globule membranes are partially ruptured by ice crystals. When we freeze the fat globule membranes are partially ruptured by the ice crystals. Therefore, frozen cream tends to oil up on thawing. That is, the oil will come out due to the rupture of the membrane, especially if the thawing is done at a higher temperature. This oiling up impairs the whipping property of the fat or cream, because this cream will be used for making ice cream, and that time there is an incorporation of air, that is whipping, so that will be affected due to this oiling up, and this can be partially prevented by adding sucrose at 10 to 15% to cream before freezing. So before freezing, if we add sucrose 10 to 15%, to some extent it can prevent the oiling up after thawing. This is in case of frozen cream. Now we will see about sour cream. This is heavy bodied ripened cream of high acidity, that is up to 0.6% lactic acid. Here clean flavor and smooth texture made by inoculating sweet, pasteurized and homogenized cream with a culture of lactic acid bacteria. So this is a cream, sour cream, which is produced from the fresh sweet cream by fermenting with lactic acid bacteria. So it will have an acidity of 0.6%. Then there is clotted cream. This is prepared by heating cream to 77 to 88 degrees Celsius in shallow pans and then allowing it to cool slowly. The surface layer consists of clotted cream which is skimmed off and strained. So this is a special kind of clotted cream. Now we are at the end of today's lecture, that is on cream separation and processing. So let me summarize. We have discussed about what is cream and different types of cream, then different properties and factors affecting those properties. We have discussed about methods of separation with more details on centrifugal methods and how the factors affecting the efficiency or fat percent in the cream. Then we have discussed about the processing of cream, that is pasteurization by different methods, especially Vacreation is more commonly used, and we have discussed all the details about the processing of different kinds of uh, cream like canned cream, frozen cream, plastic cream, sour cream, and we have discussed also the different factors affecting in the quality of cream or properties of cream.